Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, so there are 11 people currently watching. So I'm not sure what happens to the rest 87 students of mine. Okay, perhaps they are still sleeping. Okay, so for today's lecture, we're going to discuss some of the past year questions, yeah? Okay, in the tutorial book. Okay, so that you can see the pattern of this topic, topic 10 questions. Not the past year in the book. Okay, because I'm sure some of you have even finished the past year questions in the book. So I'm going to use different set of past year questions in the recent years. Okay, before that, so let's greet everyone here. Waalaikumsalam Zaf. Good morning Pichong. Waalaikumsalam Najwa. Hi Shikin. Waalaikumsalam Mai. Good morning Gan. Good morning Jeannie. Good morning Jocelyn. Okay, so these are loyal students of mine. Okay, so I hope you can stay with me throughout the discussion. Okay, and yeah. Good morning Jiva. Alright, because this topic is quite important, yeah. Okay, after topic 9, so this is the second largest mark contributor. Okay, so I always say this, so you might be boring, yeah, hearing about this all the time, but yeah, that's it. If you want to score A for maths, so you need to pay attention to topic 9 and topic 10, yeah. Hi Shah. Good morning Yuhan. Hi Kudin. Waalaikumsalam Kai. Good morning Khair. Hi Frizan. Okay, so again, if you have any problems or if you have anything to ask, okay, or if you need further explanation, particularly based on this topic, so you can just ask in the live chat, yeah. Okay, so now let's begin our discussion. Okay, so this is basically summary of topic 10, okay, that you already have and you already printed out this. Okay, so yeah, I hope this can be a help, okay, to you whenever you need to solve problems on this topic, yeah. Okay, so let's begin our discussion. So I will start with past year questions 17, 18. Okay, because last time we stopped until 16, 17, right? Okay, and again, the tip is, okay, whenever, okay, you come across this question, okay, so please allocate 1 minute for 1 mark question. All right, so let's begin. Okay, so now we have this question: the number of text messages, all right, received by Rosnaida during a fixed time interval is distributed with mean of 6 messages per hour. Okay, so now we know that we are talking about number of text messages, so it has to be discrete, right? Discrete random variable. Okay, so and yeah, again, between for discrete random variable, we do have two distributions here that can be used to model. It's either binomial and Poisson. Okay, so now the problem is which one to choose. All right, so but let's have a look at the question here. Okay, we are given the mean, okay, which 6 messages per hour. So now the hint is here, you do have the time interval. Okay, so now if you do have the time interval, okay, so which means it has to be Poisson. And not only that, we are given the mean. Okay, so it has to be Poisson distribution, not binomial. Why? Because for binomial distribution, we must have the n and the p. But for Poisson, we must have the lambda, which is the mean. Okay, so in this case, because we are given the mean, so it has to be Poisson distribution. Okay, so my advice is every time you have this, okay, so please declare your random variable. So you may see here, okay, so I declare the variable here x to be a number of messages received in 1 hour, okay, because it's stated here per hour, right? Okay, so x can be distributed using Poisson distribution with lambda 6. Alright, okay, so now the question says, okay, so there are 3 marks here. So the tip is please allocate only 3 minutes for this particular question. So the question says, find the probability that Rosnaida will receive exactly 8, okay, exactly 8 text messages between 4 o'clock and 6 o'clock on a particular day. So, okay, between 4 and 6 o'clock, so you know it is 2 hours, right? Okay, so it is 2 hours. So now, because previously we declared the random variable to be number of messages in 1 hour. So now, in order to answer this particular question, I'm going to declare a new random variable, which is y. Okay, so I declare, you may choose any other letter. Okay, except for this x, okay, because we have used the x to represent the number of messages received in 1 hour. So now we use another letter to represent number of messages received in 2 hours. So now you can see as the time interval has doubled, so the lambda also will be doubled. Okay, so from 6 now we have 12. Yeah? The lambda value is 12. Okay, so the question says find probability that Rosnida will receive exactly 6. Exactly 8. So exactly 8 means we are looking for probability y equals 8. Yeah. So this is the solution, okay, because this is Poisson distribution. Okay, so in order to answer this one, so we just use the formula. So the formula of x, okay, equals r. So for Poisson distribution, the formula is e to the power of negative lambda times lambda to the power of r divided by r factorial. Okay, and you don't have to worry, this formula will be provided in exam. Okay, so we are done with this. Okay, so as soon as you get this answer, you will get 3 marks. Okay. Okay, now let's continue with the next question. Okay, so it is known that Rosnaida has received. Alright, so please be alert here. It is known that. Okay, diketahui bahawa. Okay, tengok diketahui bahawa. So we know that this event has already happened. Okay, so has received. So this one has happened. Yeah? So the idea is, okay, because of this statement, this event has already happened. Okay, so we are sure that it has happened. So it is known that Rosnada has received at least text messages. Okay, so at least text messages means, okay, between 4 o'clock and 6 o'clock, which means in 2 hours duration, right? So we are still talking about y. Yeah? So at least 10, so means y greater equal 10. Okay, so this event has happened. So now the question says, find the probability that she received 13 text messages during that time interval. So now, during that time interval means still the time interval of 2 hours, yeah? So we are still talking about variable y, yeah? Because previously we have declared, right, y to be number of messages received in 2 hours. Okay, so now, what is the probability that she received 13? So now the question says, find probability y equals 13. Okay, provided that this has already happened. So this has something to do with conditional probability. Okay, so you can see that at first this question involves topic 10. Okay, because we use Poisson distribution to declare the random variable. But then, okay, we involve topic 8, which we have conditional probability in this case, okay, because one event has already happened, so we just need to find the probability of another event. So now, this is the event that has happened, yeah. So given that she has received at least 10 messages, yeah, so this event has already happened. So now how to find probability of y equals 13. So this is how to write down. Yeah? So the question says, what is the probability of Rosnaida receives 13 messages, provided that she has already received at least 10 messages. So using conditional probability, so we need to use the formula. Okay, so it has to be y equals 13 intersect, yeah, because let's recall conditional probability formula. So if you have probability of A given B, so the formula is it's PA intersect B over PB. Okay, so this is the event of A and this is the event of B. Okay, so now this is A intersect B. Okay, so how do we obtain this value? Okay, so if you have a look at this, how to find intersection, yeah? Okay, let us draw a number line. Okay, now you have y equals 13. So y equals 13 is this particular dot. And then y greater equal 10. So this is your 10. And greater equal means, okay, from 10 to the right. So now if we find the intersection between this dot and this line, for sure you will get only this dot as the intersection. Alright, so for this intersection, so this is basically probability of y equals 13 because again, intersection of this A and B is basically A. Alright, so this is the event. So we have got the value earlier, so we just bring it down. Okay, so this is the value 0.1056 and then probability of y greater equal 10. So you can just read table. okay, where the lambda is, okay, the lambda is 12 in this case, yeah. So you just read table, lambda is 12. So when R is 10, so you can have this probability from table, yeah. So this value we obtain from table, and this value we obtain from the formula. Okay, so you just divide the two values and you will get this answer. Okay, so as soon as you get this answer, then you will get 4 marks. Alright. Okay, so again guys, if you have any question to ask, so you just ask in the live chat, yeah. So I will try to answer your question. Alright, so now let's move on to the next question, number 9. So this is the second question involving topic 10 in this particular year. Okay, so let's have a read. In every delivery of cupcakes to a particular restaurant, 30% will be returned due to not favored by cupcake lovers. Okay, so okay, now what do we have? Okay, we have 30%, okay, to be the probability. All right, and then suppose 20 of the cupcakes are randomly selected. Okay, now from this statement, you know that this is going to be your n, okay, the number of sample, and this is going to be probability of success. So, okay, if you have got the n and the p, so for sure it's going to be binomial distribution, yeah. Why? Because only binomial distribution can be used, okay, to model discrete random variable provided that we are given the n and the p. Okay, so suppose 20 of the cupcakes are randomly selected from a delivery. So what is the probability that at most 5 will be returned? So at most 5 will be returned. Okay, so how to answer this question? Right, so first, okay, I would advise you to declare the random variable. So x is number of cupcakes returned. Okay, and it can be distributed using binomial distribution with n20 and probability of success 0.3. Where do we obtain 0.3? From this, 30%. Okay, we just change the percentage to probability, so you will get 0.3. Okay, now the question says, what is the probability that at most 5? So how to write at most 5 in mathematics symbol? Okay, mathematical symbol. So at most 5 would be less equal 5. Okay, paling banyak 5. So it has to be the most 5. And it can be less than 5, but not more than 5, yeah. Okay, so it will be less equal 5. Okay, but then how? We cannot read the table, right? Because in order to read binomial table, so we must have, okay, probability of x greater equal r, yeah. So in this case, because we have less equal, so what do we do? Okay, if you don't have any idea how to get the complement of it, so you just draw number line. So now the idea is we want 5 to the left. So what don't we want? Okay, we don't want 6 to the right, right? So we don't want 6 to the right. So since we don't want this 6 to the right, so it's going to be 1 minus probability of x greater equal 6. And then here you may read the table, binomial table with n20 and probability of success 0.3. So as soon as you read the table, so this is the value that you're going to get, and this will be the final answer. Okay, you just press calculator and you will get this value. Alright, okay. Or if you want to use formula, if you don't want to read table, so probability of x less equal 5 would be probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2, so on and so forth, until probability of x equals 5. So, but I would not advise you to use this method, okay, because it's time consuming. So here I write this down, not advisable, because this is time consuming. Okay, again, because you see, as you can see here, okay, there are only 3 marks. So you have to answer this question within 3 minutes. Okay, so because this is time consuming, you just avoid using formula and you just use table, yeah. Okay, so that is my advice. Alright, so now next, we continue to the next question, B. Okay, suppose the restaurant will be holding an event which requires an order of 200. Okay, so now this is the end. Okay, so this is the end, 200 cupcakes from the same supplier. So approximate the probability that between 56 and 62 of the cupcakes will be returned. Okay, so now we are still talking about the number of cupcakes returned. So it's still x, yeah? So I don't change the random variable, it remains as x. But then, okay, the difference between the A part and the B part is that you can see that the n gets larger here. Okay, previously the n was 20, right? So this is n 20. Okay, but now the n gets larger, given in the B part, the n gets larger, which is 200. Okay, and the question says approximate. Okay, but if you have a look at this and 200, so you will not be able to read the binomial table, because okay, we know that the maximum value of n in binomial table is 50. So in this case, we need to do normal approximation. Okay, so in this case, we are going to change this binomial distribution to normal distribution. Yeah, so originally this used to be discrete random variable because we are talking about number of cupcakes, but now it's going to be continuous. Okay, because we are going to do normal approximation. Okay, so first, okay, we find the NP and also NPQ. So this is your N and this is your P, and for sure Q we know is 1 minus P, which is 0.7. So NP is 60 and NPQ is 42. So you will have, okay, this mean to be 60 and the variance is 42. Okay, now what do we do? So now the question says find the probability that between, yeah, so the word is between. So between means, okay, it has to be this 56, 62, okay, without the equal sign. Okay, between, and there's no word inclusive right after that. So there's no word inclusive means it's going to be between 56 and 62. So x greater than 56 and less than 62. So this is how we write down the mathematical representation of the statement between 56 and 62. Okay, but then before we can find the probability, we need to do continuity correction because, okay, it used to be discrete random variable, so and we changed this to continuous, right? So this is the process of continuity correction, yeah. Okay, so we need to do continuity correction with this call. So what do we do again? Okay, as I advise you, okay, in the during tutorial session, okay, in the classroom, where you don't have to memorize, yeah, you don't have to memorize the formula of continuity correction. So what you need to do is you just draw the bar. Okay, so in this case, because we have two different values, so we're going to draw two bars here, 56 and 62. Okay, now you want the region in between, right? So you shade the region here in between. Okay, and okay, now because there's no equal sign, right? So there's no equal sign, which means this bar is not going to be shaded. So it will stop here. So it will begin, okay, at 56.5. And next, okay, there's no equal sign here. So again, this bar is not going to be shaded. So it will stop here. So you know this is 61.5. Why? Because from this 62, you just subtract with 0.5 and you'll get 61.5. Okay, so you can see here, this is the process of continuity correction. Yeah. So after we do continuity correction, we still cannot read the normal table. Okay, so now from discrete it has become continuous, right? But then we cannot read the normal table. Why? Because we only have standard normal table. So next, what do you need to do is standardization. So standardization can be done by subtracting the score with the mean and divided by standard deviation. Here we also subtract with the mean divided by standard deviation, and okay, you give the value correct to two decimal places, yeah, because we can only read the standard normal table if we have the z-score to be two decimal places. Alright, so now we want this region, negative 0.54 and 0.23. So if we draw the bell-shaped curve, so it's going to be here. Okay, so this is the region, yeah, after we draw the bell-shaped curve. So, okay, how do we find the probability? So it's going to be 1 minus this region, because we don't want this, and also this region we don't want this, we don't want the region on the left of negative 0.54, and we don't want the region on the right of 0.23. Okay, but then the problem here, we cannot read the table, right? So this one we cannot read table. But if you notice, okay, so if you draw the bell-shaped curve, so this is negative 0.54. Okay, so this is the region that we don't want right here. So if we rotate this, so this is going to be the region where it's greater than 0.54. So this region is basically has the same area as this region. So we just change this from z less than negative 0.54 to z greater than positive 0.54. And then you can read the standard normal table. Here you will get the reading. And here also you just read the normal table, standard normal table, and you will have this answer. Okay, so please bear in mind there are how many marks here? 5 marks. As I told you before, so 5 marks. Okay, so perhaps the K1 will be given once you obtain the Okay, the NP and PQ, and then next continuity correction, standardization, and then when you read the table, then for a final answer. Okay, so where the marks coming from, yeah. Okay, so then next. Okay, so please remember, so as we do normal approximation, so there must be two steps here. We need to show clearly. One is continuity correction, and the second one is standardization. Okay, so now next. If the probability of observing less than n numbers, okay, so observing less than n numbers of cupcakes among those delivered which are returned is 0.992. So how to write this, yeah, in mathematical representation? So observing less than n, so we know less than n, it will be this, x less than n, yeah. And then the probability is 0.992. So it's given here. So we just bring it down. So how to write this is actually probability of x less than n equals 0.992. So from this statement here, we just change this to mathematical representation. Okay, then the question says use the normal approximation to determine the value of n. Okay, so now what do we do? Okay, because the n, yeah, so we don't know the n, right? So the question says using normal approximation. So, okay, because this n is coming from discrete, right? So what do? We do continuity correction first. Okay, and how to do continuity correction? We do have formula, but you don't have to memorize it. What you need to do is you just draw this bar. Okay, so now this is n. Okay, and you want the region less than, right? So less than means you shade the region on the left of n. Okay, and then next, because there's no equal sign here, so this bar is going to be empty. Yeah, we don't have to shade the region. So we stop here. So here is going to be n minus 0.5. Okay, so this is it. N minus 0.5, yeah, after we do continuity correction. Okay, and then next we do standardization. Okay, so we minus with the mean divided by the standard deviation, and this is what we get. Okay, this is what we get. Okay, if you draw the bell-shaped curve, you will notice that this area is approaches 1, right? So, okay, this value is approaching 1. So you know that, yeah, the area is too big. So the height, okay, so we know that this z-score is located on the right of 0 lah. Okay, because if you try to do this way, okay, if you take this, okay, this is 0. If you assume that the z-score is here, so we know that the area here is not going to be as big as 0.9, because we know the area on the left of 0 is 0.5. Okay, so if we try to assume the region is here, so it's not going to be true, because the area here has to be less than 0.5. Okay, so that's the possibility that we have to exclude. Alright, so we exclude this case. So the only chance that this z-score is located, okay, this z-score is located on the right of 0. Okay, because you can see that the probability is so big here, 0.992. Okay, and we know that this z-score is going to be positive. But then how to obtain this? Okay, because we can't read the table yet. So what do? We just do, okay, so if we take 1 minus, yeah, so if you do 1 minus this region, okay, so this is the region where z greater than, so if we do 1 minus, so we will get the probability to be 0.008. Okay, then if you read the standard normal table, okay, so if you read the standard normal table, so its probability of z greater than 2.4089. Okay, and you may find this value from page 24, yeah. Okay, from your statistical book. Okay, so you can turn to page 24 to read this. Okay, to have this value 2.4089, and then you just equate these two, and you will notice that the n is 76.11. But now because we are dealing with the number of cupcakes, right? So it is 76 cupcakes. Alright. Okay, so now you can see here there are 5 marks for this particular question. Okay, yeah, why it's quite big? Because of this step. Okay, you can see that we are performing continuity correction, standardization, and we also read the table. Okay, and finally we get the value. Okay, so there are 5 marks here. Alright, okay, so we are done with this question, 17, 18, yeah? Okay, so I hope that you now understand this. Okay, so now let's continue with the following year, 18, 19. Okay, so 18, 19. Okay, for this particular year, there are, the format was quite different, yeah, last time, 18, 19. because this topic appeared in both papers, paper 1 and paper 2. Okay. So now let's have a look at this. Okay, so the amount of cement packed by a machine is normally distributed. Okay, so you can see clearly here it's normal distribution and it's amount of cement, right? So it has something to do with the weight. All right, so it has something to do with the weight. So now that's why you can see here I declare the random variable as weights of cement bag. Okay, and it can be it is it can be modeled using normal distribution with mean 39.3 and the standard deviation is 0.9. So how to write this down? You write down 0.9 squared. Why? Because the general form of normal distribution is this. Yeah, we use the mu to represent the mean and this sigma squared to represent the variance. So if you are given the standard deviation, so you just square the value to get the variance lah. Okay, so now the question says find the probability that the bag weighs more than 40. So more than 40 means it's going to be greater than 40 itself. Okay, so in this case, it has nothing to do with normal approximation. Why? Because this is already continuous random variable. So this is already continuous variable where we use the normal distribution to model this random variable. Okay, so we just need to do standardization. So this is the process of standardization. Okay, why do we do this standardization? So that we can read the standard normal table. Okay, so z greater than 40 minus 39.3. Okay, the mean, and we divide by the standard deviation. So we get this z score 0.78 and we just read the standard normal table and this is the value. Okay, there are 2 marks only here, so don't spend too much time on this kind of question. Okay, next, B. Alright, so if the probability of the bag weighs not more than M. So here the keyword here not more than M. Tidak melebihi M, ya. Okay, so is 0.95. So determine the value of M. So now how to write down? So we know that not more than M is basically X less equal M. Okay, and the probability is given as 0.95. So how to determine the value of M? Okay, now the idea is because this is already normal distribution, so no continuity correction is needed. Please bear in mind because this is already normal distribution. So I need to remind you this. So no continuity correction is needed. So we just do standardization here. Okay, because sometimes students they get confused. Okay, madam, when to perform continuity correction and when not to perform. So this time we don't have to perform continuity correction. Why? Because our data is already continuous. Again, here, this is continuous, yeah. Okay, so because we are talking about weights, okay, weights of cement bag. Okay, so it is continuous, so we don't need to do continuity correction because it's already continuous. And we just do standardization. Okay, so we just subtract the M with the mean divided by standard deviation and we equate to 0.95. And again, because you can see the area is too big, so for sure that the Z score is located here on the right of 0. Yeah, so this is 0. Okay, so this is the area 0.95. Okay, now how to get this? Okay, because we can't read table, so it's 1 minus Z greater than this. Okay, so we don't want this region, right? So 1 minus this is 0.95. So 1 minus 0.95 is 0.05. And then, so where can you have this Z score? So again, you turn to page 24. Yeah? Okay, you turn to page 24 and you will have this Z score, 1.6449. And then you will have the reading, the probability is 0.05. And then you just equate these two. Okay, so you will see that, okay, the M is going to be 40.8. Okay, so this value, because we are talking about weight, right, and it is continuous, so you don't have to round it off. Okay, this is quite different from previous year that we discussed just now. Okay, the previous year we are talking about number of cupcakes. Okay, so number of cupcakes, after you get the value, you round it off. Okay, because the cupcakes is discrete, right? We are talking about countable figure. So when it's countable, so for sure, okay, it can be in decimal. So from 76.11, you just change it to 76. But now here, we are talking about weights, okay, weight of cement bag. So it can be in decimal, so you just leave the answer as it is here, 40.8 kg. You don't have to round it off. Okay, so I hope it's clear by now, yeah? Okay, now, next, the question says, okay, a total of 5 bags of cement are chosen. Okay, so now we are not talking about the weight, we are talking about the number of bags. Okay, so total of 5 bags. So this is N. So a total of 5 bags of cement are chosen at random. So find the probability that at least 4 bags weigh more than 40 kg. So now, okay, more than 40 kg. Where have you seen this before? More than 40 kg. It's coming from the A part just now, right? Okay, so if you notice, from the A part, okay, probability of X greater than 40 is this. Okay, let's have a look. Probability of X greater than 40, okay, the weight of cement is greater than 40 is this. So this value is going to be the probability of success. Okay, so this is going to be the probability of success for this random variable. So here I declare a new random variable y to be number of bags weigh more than 40 kg. Okay, now we are not talking about the weight anymore. We are talking about number of bags with weight more than 40 kg. So now it can be modeled using binomial distribution with N5, and this is the probability of success that we have obtained earlier from the A part. Yeah, so this is from A. Okay, so this value is from A. Okay, and now the question says find the probability that at least 4 bags. So at least 4 means, okay, so at least 4 bags means y greater equal 4. And because we know, okay, the total number of bags is 5, right? So greater equal 4 means it's only y equals 4 and y equals 5. Okay, and because you see the probability of success here is 0.2177. So you cannot find this P from the binomial table, right? So in this case, the only way of solving this problem is by using formula. So we only apply formula. Okay, because this value, okay, there's cannot be found in normal table, yeah. Okay, so it is nowhere to be found in binomial table. So in this case, binomial table cannot be used. So we just need to use formula to solve this problem. So we just use the binomial formula. Okay, so 5C4 times P to the power of 4 multiplied Q power of 1, and then here also, and you get this value. Okay. Alright, so this is question from 2018-19. Okay, paper 1. Okay, now next. Okay, let's discuss 18-19, paper 2. Okay, so here we do have this number of batteries sold. So number of batteries is countable, right? So it is discrete, yeah. So number of batteries is discrete. Okay, and then it's about what? Okay, sold at service center on any particular day. So the keyword here, on any particular day. So in a day. Okay, so we are talking about number of batteries sold in a day. So it's already, okay, it's stated here follows a Poisson distribution. So okay, we may exclude the binomial distribution in this case. Okay, so now the lambda is unknown. So we do not know what the value of lambda is. So you can see here. So I declare the random variable to be number of batteries sold in a day. So now we don't know the value of lambda. Okay, but then let's read the question here. If the probability of selling exactly 4 divided by probability of selling exactly 2 is this, show that lambda is equal to 15. Okay, so now how to solve this? Alright, so because we know Poisson distribution formula, okay, so the question says if the probability of, okay, selling exactly 4 batteries divided by probability of selling exactly 2 batteries is equal to 225, okay, over 12. Okay, so again, you can see from this whole statement, from this whole sentence, I have changed this to mathematical representation. Okay, so it's Px equals 4 divided by Px equals 2 is equal to 2 to 5 divided by 12. Right, so now how to show? Okay, you just substitute into the Poisson formula. So this is e power of negative lambda. Because lambda is unknown, right? So you just substitute e power of negative lambda divided by lambda power of 4 because of this. And then divided by 4 factorial. And then the whole thing here divided by e to the power of negative lambda multiplied by lambda squared divided by, okay, 2 factorial, okay, because of these two. Okay, then you may notice that this e can be cancelled out because they are actually the same thing. Okay, but now what do we have? So we have lambda power 4 divided by 4 factorial divided by, so okay, we use this concept, a divided by a over b divided by c over d. So this is equal to what? A over b multiplied by d over c, right? So here I Okay, I swap this. So it's going to be 2 factorial divided by lambda factorial. So if you notice that, okay, 4 factorial is basically what? Okay, 4 factorial is basically equals 2 times, 4 times 3. 4 times 3 times 2 factorial, right? Okay, so then you know that, yeah, this 2 factorial can just be cancelled out, yeah? So this is 4 times 3 times 2 factorial. So this is actually 4 factorial, lah. So this 2 factorial can be cancelled out with this 2 factorial. So we have this 12. Okay, and then you just bring the 12 here. Okay, so you just bring the 12 here. So you can just cancel this one out. So you are left with, okay, 2 to 5 here. And then here lambda squared, you just cancel with this. So you will have lambda squared here. So lambda squared equals 2 to 5. So by putting square root on both sides, so you will have lambda to be plus minus 15. But now, okay, we are talking about what? Number of batteries, right? So there would be, okay, it's not possible for the number of batteries to be negative, right? So we just reject the negative value. So now lambda is 15. It's shown here. Okay, so 3 marks here. Make sure you solve this problem within 3 minutes. Okay, and now next, it's stated that, okay, on any particular day, calculate the probability that the service center sells between 5 and 14 batteries. Okay, so we are still talking about the same time interval, yeah, on any particular day. So we are still talking about X. Okay, so the lambda is still 15 in this case, yeah. Okay, so on any particular day, calculate the probability that the service center sells between 5 and 14. So we just, okay, find this probability. And because again, Poisson distribution is for discrete, right? So greater than 4 means greater than 5 here. So greater than 5 means it's greater equal 4. And less than 14 means less equal 13. Okay, because again, this is about discrete random variable. Alright, so now we want to find this. So if you run a blind, we want to find, okay, the dots here from 4 until 13. Okay, so how to read table? So what do? You just get the reading from 4 to the right. So this is 4 to the right, and then you just minus with, because you don't want 14 to the right? So this is what you don't want. So you just subtract with this. So this is going to be 14 to the right. Okay, so that's why you can find the formula here. Okay, it's 4 to the right minus with 14 to the right. Okay, and you may just read this from the Poisson table with lambda 15, yeah. So lambda 15, you just read this. Okay, lambda 15, you just find this in the Poisson table. So, okay, you will have this reading and then subtract with this reading, and finalizing the answer, you will get this. All right, so 3 marks here means 3 minutes to solve. Okay, now next. Okay, given that the probability of selling less than K, so selling less than K batteries on any particular day is 0.917. Okay, so we are given the probability. So now we just need to find the K. Alright, so selling less than K, so this is X less than K. Okay, because again, we are talking about the same time interval, yeah, on any particular day. So it's still the X. We are still talking about the random variable X. Okay, where the lambda is still 15 in this case, yeah. Lambda is still 15 because it's in a day. Okay, we are, yeah, it's about number of batteries sold in a day. So lambda is still 15. So we are given the probability that X less than K is equal to 0.917. Okay, then, yeah. So what to do? Okay, so now because it's discrete, right? So less than K means this, yeah, on the number line, this has to be K minus 1. This is K plus 1, right? Okay, because it's discrete. So you want X less than K. So less than K means empty circle from K to the left. Means it's from K minus 1 to the left. So which means what you don't want? You don't want from K to the right. So which means you don't want K to the right. You don't want this because you want from K minus 1 to the left. Okay, so that's why X less than K is, yeah, probability of X less than K is equal to 1 minus probability of X greater equal K. Okay, because actually you want K minus 1 to the left, so you don't want from K to the right. Okay, so that's why this can be, okay, represented using this 1 minus probability of X greater equal K, and then you just equate with this. And yeah, you bring this to the right. Okay, you bring this to the right and this probability to the left. So you will have probability of X greater equal K equals Okay, 0.083, and you just read the Poisson table. So from table, so this is when the lambda is 15, yeah. So you just read the Poisson table where lambda is 15. So you will see that probability of x greater equal 21 is equal to this. So you just equate these two. So you will notice that k is equal to 21. Okay, so I hope this is clear enough. Alright. So there's no question so far in the live chat. So I assume that it's clear. Are we good, guys? If we are good, then please respond in the live chat so that I know that I'm not talking to myself. Okay. Alright, so now let's continue. Okay, thank you for the response, Firzana. Yeah, Fir said faham. Terima kasih, madam. Sama-sama, Fir. Okay, so now let's continue. Okay, find the probability that exactly 40 batteries are sold in 2 working days. Okay, please be alert in the time interval, guys. So you can see that the time interval here has doubled. Alright, so now we are not talking about lambda equals 15 anymore. So this would be lambda equals 30. Okay, so I need to remind you whenever we are dealing with Poisson distribution. Okay, whenever we are dealing with Poisson distribution, okay, so please make sure, please be alert on the time interval or the space that we are given. Okay, so in this case, or okay, at first we are given, the batteries sold in a day. So now for this D part, okay, it's about batteries sold in 2 working days. So you can see that the time interval has changed. So the lambda also will change. Okay, so now you will notice that from X here, I changed the random variable to Y. So this is Y to be number of batteries sold in 2 days. So Y can be modeled using Poisson distribution with lambda 30. Okay, now the question says find probability that exactly 40. Yeah, exactly 40 means we want Y equals 40. Okay, and you just use Poisson formula and you will get this answer. Or, okay, if you prefer to read table, okay, so now the lambda is 30, yeah. So you just read table where the lambda is 30 in this case, lambda 30, and this is also lambda 30. Okay, now you want this, y equals 40, right? So if you draw a number line, so 40, so this is 40. Okay, so you want this single dot. But you don't have this single dot in the Poisson table, right? You have cumulative of, so from 40 to the right. So from 40 to the right, so this is y greater equal 40. So this is y greater equal 40. But you want this single dot only. Okay, you want this single dot. So which means you have to subtract with the rest of the dots here. So, and you know this is 41, right? So y greater equal, sorry, this should be 40. This should be 40. And then this is 41. So that's why the formula is y greater equal 40 minus y greater equal 41. The two values here, okay, obtained from the table. And okay, you will get this value. Okay, you may see that there is a slight difference in two answers because why? The values in the Poisson table are basically rounded off to 4 decimal places. So that is why there is a slight difference between this. Okay, but it's okay because both are still correct. Okay, so we are done with this year 1819. Okay, so now let's continue with the following year. Okay, 1920. Okay, so section A. So this, yeah, this was last year where the PSPM was cancelled. Okay, so the candidates didn't manage to sit for the exam. So now let's discuss the question. So in a production process of flower vases, okay, sorry, I'm going to use highlighter here. So it is known that the probability of the flower vases have the defects. Okay, have defects is 0.145. Okay, now we are talking about the probability. So this is P. Okay, now if 5 flower vases, okay, alright, so this is N. So again, whenever you have N and you have P, that means it has something to do with binomial distribution. Okay, so now we declare the random variable to be number of flower vases have defects. Okay, and now it can be modeled using binomial distribution with N5 and probability of success 0.145. Okay, now the question says find the probability that at most 2 flower vases have defects. So now at most 2. So how to write at most 2? So it is x less equal 2. Okay, so now because this is discrete, right? So less equal 2 means you want this. Okay, probability of x equals 0, x equal 1, and x equal 2. So my question is, can we read binomial table? Is there any possibility of reading table? What would be your answer? Is there any possibility of reading binomial table for this particular question? The answer would be no. Why? Okay, we cannot use. So for this particular question, we cannot use binomial table. Okay, why is that? The reason is because of this probability of success. Okay? Yeah, good. Okay. So thank you for the response. Sam, okay. Yeah, Sam says no. Okay, Jocelyn also says no. Yeah, okay. Why? Because probability of success cannot be found, okay, in the binomial table, right? Okay, so in this case, we just use the formula and make sure you press your calculator very carefully. So this would be the answer. Okay, and then, so there are 3 marks here. So please make sure you solve this question within 3 minutes only, yeah? Okay, next. Okay, in n selected flower vases at random, so now the n unknown, so the probability that none of the flower vases has defects, yeah, so we are still talking about number of flower vases have defects. So you may see that here I still get the random variable remain as x. Okay, x to be number of flower vases have defects, but it's just that the n here is unknown. We do not know what the value of n. So now, but then we are given the probability that none. Yeah, none means 0, right? So in this case, it stated that, okay, the probability that none of the flower vases have defects is at least 0.1. So how to write this? Okay, how to write the whole sentence here? How to write this whole sentence in mathematical representation? This is it. So that is the beauty of maths. You can have a long sentence, but you can only have these few symbols to represent the whole sentence. Okay. All right. So now, so this is it. How to change this? So probability of x equals 0 is greater equal 0.1. Okay. So now how to solve this problem? Okay, the n is unknown here, right? So we are going to use binomial formula. So x equals 0 means it will be nc0 times probability of success power 0 and multiplied by probability of failure power of n. Okay, and this is greater equal 0.1. But you don't really have to worry. This may look complicated, but it is not actually, because nc0 is simply 1. Why? Because if you have any number, okay, for example, 5, 6, 7, and so on, and then you want to choose nothing. Okay, 5C0 is 1. And then 7 choose 0 is also 1. Why? Because out of this stuff, you want to choose nothing. So means there's only one way of doing it. This one also only one way of doing it. Because you don't want to choose anything, right? Okay, so same thing also, if you have n and you want to choose nothing, so there's only one way of doing it. So that's why this is 0. And then here also, sorry, not 0, sorry, this is 1 and C0 is 1. And then this one power 0 is also 1. And we are left with only this one. So yeah, we want to solve this inequality. Yeah? So what do? We put log both sides. And the power here, we bring this to the front so that it will become coefficient. So we divide both sides by this value. So please bear in mind, according to the property of inequality, if you divide both sides by a negative number, so for example, yeah, if A is greater than B and C is a negative number. So C is a negative number. So if you divide both sides by a negative number, okay, like this one. So what happens to the inequality sign? It will be changed. Okay, don't forget this property. Yeah. Okay, it will be changed to less than sign. So this also happens to this one. Okay, so when you divide by log 0.855, because it's a negative number, so here we change the inequality sign to less than. Okay, so and then you just press calculator, so you will obtain n less equal 14.7, and it will be 14 verses. Why? Because yeah, it is discrete, right? So yeah, you cannot have 14.7 verses, right? So we will have 14 buses because less than. So you can see that, okay, 14.7 less than. So the next integer after 14.7, yeah, it has to be from this left. So the next integer, okay, less than 14.7 is basically 14 lah. So this is the answer. N equals 14. Okay, then next, using normal approximation, find the probability that more than 10 flower vases have defects. Okay, still, okay, we are talking about number of flower vases have defects. Okay, and now the N is 100. Okay, and the probability of success remains 0.145. Okay, because N gets larger, so the question says using normal approximation. So we get the NP and also NPQ, so we change this to normal. Okay, so please bear in mind, this is for discrete, yeah. This, okay, at first it was a discrete random variable, now we change this to continuous. So the process of changing, yeah, discrete random variable to continuous is called continuity correction. Okay, so find the probability that more than 10 flower vases have defects. So more than 10 means x greater than 10. So you do continuity correction, yeah. So greater than 10 means because of this greater, you shade the region on the right, and because there's no equal sign here, so okay, you don't have to shade this region, so it will stop here, so 10.5. So this is the process of continuity correction. And then next you do standardization. So you will find that this is negative. So if you draw the bell-shaped curve, so this is the region that we are looking for. But then we cannot read the table yet. So it's going to be 1 minus z less than. Okay, and then you change this. You rotate. So this is z greater than 1.14. And you read the table. So you will get this answer. Okay, so please bear in mind, guys, there are 5 marks here. So you can see that, yeah, for normal approximation question, there will be 5 marks altogether. So please make sure, okay, you know how to solve, yeah. Okay, and again, as I told you before in the class, so I am pretty sure that this year there will be normal approximation questions. So please be alert, yeah. Okay, normal approximation problems. So make sure you try to do as many as normal approximation problems. Okay, right now. So now we have, yeah, it's 5 minutes to 11 o'clock. So I think that is all for today, guys. So I'm going to share all the solutions that we had discussed earlier in the Google Classroom. So you just refer the solutions here, okay, and try to understand this. And if you have any problems, then you are most welcome to come to the Maths unit, okay, for consultation. Okay, guys, so thank you for your attention. Okay. All right, so thank you for your attention. Yeah, we do have one question here, but not on mathematics. So I'm going to ignore this question. Kenapa bear in mind bukan cat in mind? I'm not sure. Okay, so that's all for today, guys. Thank you for your attention and thank you for your presence here. Okay, I'm going to finish and I'm going to end the lecture with Assalamualaikum warahmatullahi wabarakatuh. Have a nice day and have a nice weekend, everyone. Bye-bye.